This is a brief overview of the automotive theme for mechanical engineering. My name is Professor Andy Cruden, and I would just like to acknowledge that these slides were prepared by Dr. Dinesh Kahanda-Korlaj. In terms of the big picture for automotive, we can see that currently there are some 1.3 billion road vehicles worldwide, and we are projecting that by 2050 there will be a further 2 billion road vehicles globally, which would give us 3.3 billion road vehicles. Clearly that's a significant challenge, but also an opportunity in terms of how we might address some of the climate change and affordability queries regarding mobility in the future. So the future of the automotive industry, there's a number of distinct challenges of it. For example, under smart sensing, we might have the Internet of Things, and looking at autonomy for cars. Can they drive themselves, be summoned drivers completely autonomously to let us again work and connect in that vehicle? In terms of connectivity, we're looking at voice recognition for some of the driver control systems, and also for the diagnostics and potentially prognostics on that. We're looking particularly at the electrification of vehicles, and that might be in terms of the drivetrain, it could be in terms of some of the auxiliary systems within it, and also the challenge in terms of lightweighting. Can we produce more sustainable, reusable materials within our vehicles? And the capability of it, again, can we provide that vehicle with additional capability, both off-road and in terms of longevity of that vehicle. So what we offer within the automotive theme is the core principles of vehicle dynamics, structural design, propulsion, and automotive electronics. And that is part of our course. You will utilise a range of engineering facilities, gain practical experience with some of our design workshops and studios. You would have the opportunity to showcase your work within our annual engineering design show. And again, crucially for our automotive students, have the opportunity to join and participate within our Formula student team. The vehicle on the left is now using a composite chassis, many carbon fibre parts within its suspension, and novel 3D metal printing for some of its suspension parts, in addition to a full aero package, front, underfloor, side pods and rear wings. So what we offer in terms of vehicle dynamics, again, the opportunity to study and learn about the handling characteristics of road vehicles and how they can be improved, both for normal vehicles and motorsport vehicles. In terms of looking at the power transmission, the powertrain chassis vibration, and that's including looking at the opportunity to replace mechanical differentials, for example, with electronic differentials if we have more than one driving motor within the vehicle. And crucially, as we look for more refinement within our vehicles, also addressing vehicle vibration and harshness. We also offer structural design, a crucial element of any vehicle in terms of the automotive structures, the body structural requirements and its torsional rigidity, understanding of material properties both for strength, lightweight, and ultimately the longevity, i.e. the corrosion resistance of that material. Again, further offer is propulsion. We are seeing a significant change from conventional combustion engine vehicles, whether that's a spark ignition engine for petrol or a compression ignition for diesel, to looking at hybrids across a whole range of different technologies, whether that's a combustion and battery engine hybrid, or a pure battery electric vehicle, or indeed a fuel cell electric vehicle, which in most instances itself is actually a fuel cell battery electric hybrid. And there's a whole range of different hybrid vehicle architectures, from series hybrid, parallel hybrid, to different series parallel hybrid combinations. For example, as embodied in the common Toyota Prius vehicle. And a whole range of different onboard systems that have to be addressed as we try and electrify and potentially remove hydraulic systems to make them more electrically actuated in the future. In terms of automotive electronics, again, increasing amount of electrical equipment and electronic equipment within the vehicle as it becomes more connected, both for infotainment, but also in terms of driving systems and driver aids, in terms of electronic steering, and that could be for lane assist. It could be for electronic suspension as we move to more adaptive suspension, able to again change both in terms of safety and general road keeping. So some of our key automotive theme modules, for example, in terms of the Part 1 and Part 2, they're quite common modules across a number of the electronic mechanical degree programme in Part 1 and Part 2, covering basics like thermal fluids, mechanical system analysis, design and computing. Moving on to Part 2, where we go into more detail in terms of some of the thermodynamics of engines, materials and structures, mechanics, machines and vibration. And this general Part 1 and Part 2 is the seed then to allow you to specialise more in Part 3 and Part 4. So in particular in Part 3, we would look at vehicle powertrain, noise and vibration, again those key elements to refine modern vehicles. Automobile systems in terms of some of its electronic systems and some of these adaptive systems I previously mentioned. Heat transfer and applications, again looking at continual refinement from some of our combustion engine technologies, and by no means least, crucially looking at manufacturing techniques and materials, including bonding and the use of composites. And in Part 4, again going on to further specialism in terms of looking at automotive propulsion and modern hybrid powertrains, as well as a more particular look in detail at advanced electrical systems, so electrical machine design and control. And all that is supported by other modules such as engineering management law, engineering design and management, again crucial in terms of career opportunities in the large automotive companies and their supply chain. As a good example of a modern electric vehicle, let's use the Jaguar I-Pace. Again, a significantly powerful vehicle with a 90 kilowatt hour battery. Again, a new modern lithium-ion pouch cell design, capable of working across very extremes of temperature and weather and weighting. We can charge that at home through a standard 7 kilowatt AC wall box, or again, this vehicle has been designed to allow rapid charging, again to improve the utility of that vehicle. It uses 2 electric motors, so again looking at vehicle control through electronic control of those systems rather than now relying on mechanical differentials. So again, looking at other facilities and stability issues that can be implemented very quickly via electronic control that may not be available through the conventional mechanical systems. And the performance of this vehicle is very substantial, for 0 to 60 in 4.5 seconds. So we're looking at powerful, modern, refined vehicles, again with good mileage and driving range capability. But we also will address continued improvement in what might be viewed as old school technology in terms of combustion engine. There are still significant advances to be made in the improvement within our conventional vehicle fleet, which, to be honest, still has a long commercial lifetime. So again, there's still significant research and commercial opportunities in improving that. And this example is of the Ford EcoBoost engine. This particular one shown here is a 3.5 litre V6, which is used in the sport cars like the GT car and some of the SUVs. But that same technology, this EcoBoost turbocharged technology, is also used in across the range for things like downsizing, where we're trying to put a much smaller capacity engine into a relatively large car. So for example, putting a 1 litre 3-cylinder EcoBoost engine into a Ford Focus. That electronically controlled turbocharger again can achieve significant power benefits, almost equivalent to a much larger engine, but still achieve very good fuel consumption. So again, there is still significant advances to be had in improving our current internal combustion engine operation. Again, the overall focus there is to ultimately reduce CO2 emissions. In terms of a career opportunity, following an automotive theme degree, many opportunities across a whole range of different disciplines, including simulation and vehicle analysis, test engineer, where again, whether it's on a rolling load dyno or out in different climatic zones, aerodynamic engineer, engine design and system engineer, and increasingly how we would look at incorporating hybrid and lightweight materials within a car. Thank you.